Okay, we're going to start into chapter 2 here. In chapter 2, it's all about linear functions and lines. So in 2.0, they just have a kind of a review of linear equations and inequalities that we'll look at. So a linear equation is an equation of the form ax plus b equals 0, where a is some number. It can't be 0, though. Okay, what if we have this equation, 4 times x minus 3 squared plus 10 equals 15 minus 5 times x plus 6, and we want to solve that for x. That would be an example of a linear equation, because if I wanted to, I could write it in the form ax plus b equals 0. Now, I'm not going to do that. I'm going to solve for x. Okay, but so to solve for x, let's distribute 4 and then distribute the negative 5 there. So it'll be 4x minus 12 plus 10 equals 15 minus 5x minus 30. Negative 12 plus 10 is negative 2, and 15 minus 30 is negative 15. So here's where I'm at so far. And let's go ahead and add 5x to both sides and add 2 to both sides. 9x plus 5x, or sorry, 4x plus 5x is 9x, and negative 15 plus 2 is negative 13. Divide by 9, so x would be negative 13 ninths. That's the answer. Okay. Here's another example. So what if I had x plus 1 divided by 3 minus 1/2 x equals 2 minus 1/6 times x times 2 minus x. I want to solve for x. So the first thing, I don't like working with fractions, right? So let's go ahead and get rid of those fractions by multiplying both sides by the common denominator on each of these fractions. So 6 would be the common denominator, like in other words, 3, 2, and 6 all go into 6 evenly. And if we multiply both sides by 6 and then distribute, 6 divided by 3 is 2, so I got 2 times x plus 1 minus half of 6 is 3, so it'll be minus 3x equals 6 times 2 is 12, minus 6 times 1/6 is 1 times 2 minus x. Okay, and that puts me back on a more familiar ground here because I no longer have fractions involved in this. Let's go ahead and distribute the 2 and then the negative 1 on the right there. So I got 2x plus 2 minus 3x equals 12 minus 2 plus x. Okay. 2x minus 3x is negative x, and 12 minus 2 is 10. So then want to get everything on to the left, or anything involved with x on the left, on the right, excuse me, and then all the other numbers let's get on the left. So with that said, I'll add x to both sides and then subtract 10 from both sides. 2 minus 10 is negative 8. X plus x is 2x. Okay, and then we're solving for x, so divide by 2. Negative 8 divided by 2 is negative 4. So x is negative 4. That'd be the answer. Okay, so there's a couple of problems like that in the section, where you're solving a linear equation. And then there's some problems where you're solving some inequalities. Okay, so an inequality means that you have a less than, a greater than, a less than or equal to, or a greater than or equal to sign. Now, the important thing with an inequality is that whenever you multiply or divide both sides by a negative number, you have to flip the sign. That's the mistake that students will make. Don't do that. Okay? Don't mess that up. So here's why we're flipping the sign. For instance, 2 is bigger than 1, right? I know that. Okay, what if I multiply both sides by negative 1? 1 times negative 1 is negative 1, and 2 times negative 1 is negative 2. What side is the bigger side? Well, negative 1 is bigger than negative 2, so I have to flip the sign. Otherwise, if I don't flip the sign, I'm not going to be saying something that's true. Here'd be another example. So, 2 is bigger than 1. Okay, now what if I divide both sides by negative 2? 1 divided by negative 2 is negative 1/2 on the left. 2 divided by negative 2 is negative 1 on the right. What side is the bigger side? Well, negative 1/2 is bigger than negative 1, so I have to flip the sign. Otherwise, if I don't, I'm not saying something that's true. Okay, so again, whenever you multiply or divide both sides of an inequality by a negative, you have to flip the sign. That's the number one mistake that students will make, is that they'll forget to flip the sign. Okay, don't do that. So let's take a look at some examples. What if we want to solve the inequality given by 1 minus 2x greater than 2 minus 3x over negative 4? Solve for x. Okay, let me begin by multiplying both sides by negative 4. So on the left, I'll have negative 4 plus 8x. And then on the right, I just have 2 minus 3x. Okay, because the negative 4s would cancel. Now, because I multiply both sides by a negative number, negative 4, I have to flip the sign. Okay? Let's get x on the left, all the other numbers on the right. So if I add 3x and add 4, 8x plus 3x is 11x on the left. 2 plus 4 is 6 on the right. And then divide both sides by 11. So x would be some number that's less than 6/11. Okay? Now, here's another thing that's different from an equation versus an inequality. So when you have an inequality, you have an infinite number of answers. That's not the case when I have an equation, right? When I have an equation, I just have one answer, or maybe there's 2 answers or something like that, okay? There's always a finite number of numbers, and that's not the case with an inequality. So the point is to say that whenever you're solving an inequality, you have to write your answer using set notation or interval notation. I don't care which one you use, just make sure that you're using one or the other there, okay? So as a set, I'll say the set of all x such that x is less than 6/11. And if I wanted to use interval notation, anything less than 6/11 means I'm heading towards negative infinity. And so I have negative infinity to 6/11 as a parentheses at both ends, right? Because we're not including 6/11. So either one of these two forms would be the answer, okay? You don't have to be the brave person to write down both forms. And one's right and the other's wrong. It's like how you grade that, okay? So just pick whatever form you like better and use it for that problem, okay? However, make sure that you're good with both set notation and interval notation, because you'll see those all over the place in the whole book, okay? So we got to make sure that we're writing things down correctly there. All right, here's another example. So what if I wanted to solve the inequality given by negative 2 times 5 plus 3x less than or equal to 6 minus 2 times x minus 2? Okay, solve for x. Well, let's begin by distributing negative 2 into both sides there. So negative 2 times 5 is negative 10. Negative 2 times 3x is minus 6x. And then on the right, I've got 6 minus 2x plus 4. 6 plus 4 is 10, right? And so then the next thing, I'm going to add 2x to both sides and then add 10 to both sides. Negative 6x plus 2x is negative 4x on the left. And then I'm adding 10 to both sides. 10 plus 10 is 20 on the right. Okay. The next thing would be to divide both sides by negative 4. So that way you'll have x all alone on the left. 20 over negative 4 is negative 5 on the right. And because you just divided both sides by negative 4, you have to flip the sign. Okay, so anything that's greater than or equal to negative 5 is going to be an answer. It's going to make this original inequality a true statement. Anything that's less than negative 5, we don't want that, because otherwise we're saying something that's false. So as a set, I'm going to say it's the set of all x such that x is greater than or equal to -5. And as an interval, anything that's greater than or equal to -5 means I'm heading out towards infinity. We're including -5, so make sure you got a bracket by -5 there. And there's always going to be a parentheses by the infinity sign and the negative infinity sign, right? Those are not numbers. Okay. The next thing is a definition. It says the expression a less than x less than b is called the compound inequality, or sometimes we call it a three-part inequality because there's a left part, a middle part, and a right part. Okay. And a compound inequality means that if I split it, I have two inequalities. A is less than x, and x is less than b. And is a key word there, okay? For something that we're going to do a little later in this chapter, that's going to be key, okay? So let's go ahead and look at some examples of that. What if I want to solve the inequality given by -4 less than or equal to 9x plus 14 less than 21? Solve for x. Okay. Well, let me go ahead and split the compound inequality into two inequalities. You don't have to split it. I'll comment on that at the end. But if I do here, I have -4 less than or equal to 9x plus 14 and 9x plus 14 less than 21. And the idea with splitting it is because then I can focus on each inequality individually. So if I start with this one, let's subtract 14 from both sides. We got -18 less than or equal to 9x. Divide by 9. 9 is a positive number, so we're not flipping any sign there. It looks like x is greater than or equal to -2. Okay, and go ahead and write that keyword down. That's a keyword in the problem. Yeah, do the same thing on the other inequality. Subtract 14 and divide by 9. So when I subtract 14, I get 9x less than 7, and divide by 9. 9 is a positive number, so I'm not flipping the sign there. Looks like x is less than 7/9. So what we're saying is that x has to be a number that is both less than 7/9 and greater than or equal to -2. Okay, so there would be that statement written as a compound inequality. So I'm putting it back together again. Now, my answer always has to be written as a set or as an interval. So as a set, I'm going to say it's the set of all x such that x is greater than or equal to -2 and less than 7/9. Okay, and as an interval, I have the interval -2 to 7/9. Make sure there's a bracket by -2 because you're including -2. Parentheses by 7/9, you're not including 7/9. Okay, either one of these two forms would be the answer. You're not done with the problem until you have the answer written either as a set or as an interval. Okay, so I wouldn't circle this and call it good, right? Because I'm not going to get full credit then, right? Because I don't know what's the answer. Okay, so make sure that you're writing the answer as a set or as an interval. Okay. Now I sometimes get the question, do I have to split up a compound inequality like we did here? Because we're just going to put it back together again anyway. So the answer is no. You don't have to split it because you're just going to put it back together again anyway, right? So the more you do with this stuff, the less steps you'll have to take to get the answer. Okay. So like if I wanted to keep it in compound form throughout the whole calculation, I could do that. The goal there would be to get x alone in the middle. Okay, but yeah, you're going to have to put it together again anyway to give the answer. Okay. Let's take a look at another example. So what if I wanted to solve the inequality given by 1 less than or equal to 4x minus 5 over -2 less than 9? And to solve that, why don't we keep this in compound form throughout the whole calculation? Okay, so now if I'm doing it like that, I need to get x all alone in the middle. That's the goal. let's multiply throughout the three parts here by -2 to start. So 1 times -2 is -2. In the middle, I'll have 4x minus 5, because the -2's would cancel. And on the right, 9 times -2 is -18. Also, because I just multiplied by -2, I have to flip the signs. Okay, so that'd be one thing to note. You know, if you're keeping this in compound form throughout the whole calculation, you're flipping both signs, not just one sign. Okay, if you multiply or divide by a negative. So then the next thing, let's add 5 throughout these three parts here. -2 plus 5 is 3. 4x minus 5 plus 5 would be 4x in the middle. And then -18 plus 5 is -13 at the end. Okay, and then divide throughout these three parts by 4. 4 is a positive number, so I don't have to worry about flipping the signs. I have 3/4 greater than or equal to x greater than -13/4. Okay, now I'm going to write that statement as -13/4 less than x less than or equal to 3/4. I don't need to write it like that. It's just usually when you look at a mathematical expression, usually you'll see the smaller numbers first and the bigger numbers second as you read it left to right. So my answer has to be written as a set or as an interval. So as a set, I'd say the set of all x such that x is greater than -13/4 and less than or equal to 3/4. Now, if I wanted to, I could say the set of all x such that 3/4 greater than or equal to x greater than -13/4. That's the same thing, okay? Again, the whole idea for flipping these two sides here is because you'll see the smaller numbers first and the bigger numbers second, okay? Now, if I'm writing my answer as an interval, I have to flip the sides, okay? Because with interval notation, order matters, right? We always want the smaller number first and the bigger number second as we read this from left to right. So I'm going to have -13/4 and 3/4 on the right. There's a bracket by 3/4 because we're including 3/4. We're not including -13/4, so I'd want a parentheses there on the left. Okay, and that'd be the answer there. For homework, be sure to look at the problems on page 108 there. And okay, we'll go ahead and stop the video here at this spot, and I'll start in on 2.1 and 2.2 in the next video.